Hello everyone, welcome to this interesting session of Spark Streaming from Edureka. What is Spark Streaming? Is it like really important? Definitely yes. Is it really hot? Definitely yes. That's the reason we are learning this technology, and this is one of the very hot thing in the market. When I say hot thing, means in terms of job market I'm talking about. So let's see what will be our agenda for today. So we are going to discuss about Spark ecosystem, where we are going to see that, okay, what is Spark, how Spark streaming fits in our Spark ecosystem, why Spark streaming. We are going to have an overview of Spark streaming, kind of getting into the basics of that. We will learn about DStream. We will learn also about DStream Transformations. We will be learning about caching and persistence, accumulators, broadcast variables, checkpoints. These are like advanced concept of Spark streaming. And then in the end, we will walk through a use case of Twitter sentiment analysis. Now, what is streaming? Let's understand that. So let me start by an example to you. So let's say if there's a bank, and in bank, definitely I'm pretty sure all of you must have used credit card, debit card, all those cards what banks provide. Now, let's say you have done a transaction from India just now, and within an hour, your card is getting swiped in US. Is it even possible for your card to reach in an hour to US? Definitely no. Now, how that bank will realize that it is a fraud transaction? Because bank cannot let that transaction happen. They need to stop it at the time of when it is getting swiped. Either they can block it, give a call to you, ask you whether it is a genuine transaction or not, do something of that sort. Now, do you think they will put some manual person behind the scene that will be looking at all the transaction and he will block it manually? No. So they require something of the sort where the data will be getting streamed, and at the real time they should be able to catch with the help of some pattern. They will do some processing and they will get some pattern out of it, which if it is not sounding like a genuine transaction, they will immediately either block it or give you a call, maybe send you an OTP to confirm whether it's a genuine transaction or not. They will not wait till the next day to kind of complete that transaction. Otherwise, if fraud happens, nobody is going to trust that bank, right? So that is how we work on streaming. Now, someone have mentioned that without stream, processing of data is not even possible. In fact, we can see that there is no even big data which is possible. We cannot even talk about Internet of Things, right? And this is a very famous statement from Dana Sandhu from SQL Stream. Lot of companies like YouTube, Netflix, Facebook, Twitter, iTunes, Pandora, all these companies are using Spark streaming. Now, what is this? We have just seen with an example to kind of got an idea about streaming part. Now, as I said, with the time growing, with the internet growing, these streaming technologies are becoming popular day by day. It's a technique to transfer the data so that it can be processed as a steady and continuous stream. Means immediately as and when the data is coming, you are continuously processing it as well. In fact, this real-time streaming is what is driving today this big data and also Internet of Things. Now, there will be a lot of things like fundamental unit of streaming will be a stream. We will also be transforming our stream. We will be doing it. In fact, the companies are using it with their business intelligence. We will see more details in further of the slides. But before that, we will be talking about Spark ecosystem. When we talk about Spark ecosystem, there are multiple libraries which are present in it. First one is Spark SQL. Now, in Spark SQL is like where you can, a SQL developer can write the query in a SQL way, and it is going to get convert into a Spark way and then going to give you output. Kind of analogous to Hive, but it is going to be faster in comparison to Hive. When we talk about Spark streaming, that is what we are going to learn. It is going to enable all the analytical and interactive applications for your live streaming data. MLlib. MLlib is mostly for machine learning, and in fact, the interesting part about MLlib is that it is completely replacing Mahout. In fact, it has almost replaced Mahout. All the core contributors of Mahout have moved in towards the MLlib side because of the faster response. Performance is really good in MLlib. GraphX. GraphX, okay, let me give you an example. Everybody must have used Google Maps, right? Now, what you do in Google Maps, you search for the path. You put your source, you put your destination. Now, when you just search for the path, it searches multiple paths and then provide you an optimal path, right? Now, how it's providing the optimal path? These things can be done with the help of graphics. So wherever you can create a kind of a graphical structure, we will say that we can use graphics. Spark R. Now, this is the kind of a package provided for R. So R is an open source, which is mostly used by analysts. And now Spark community want, in fact, all the analysts kind of to move towards the Spark framework. And that's the reason they have recently started supporting Spark R, where all the analysts can now execute the query using Spark environment, thus getting better performance, and they can also work on big data. That's all about the ecosystem part. Below this, we are going to have a core engine. Core engine is the one which defines all the basics of Apache Spark. All the RDD related stuff and all is going to be defined in your Spark core engine. Moving further, now, so as we have just discussed this part, we are going to now discuss Spark streaming engine, which is going to enable analytical and interactive app for live streaming data. Now, why Spark streaming? If I talk about why Spark streaming, definitely we have just got an answer. Definitely it's very important. That's the reason we are learning it. But this is so powerful that it is used now by a lot of companies to perform their marketing. They kind of are getting an idea that what a customer is looking for. In fact, we are going to learn a use case of similar to that, where we are going to use Spark streaming. Now, where we are going to use a Twitter sentimental analysis, which can be used for your prices management. Maybe you want to check how your product's gonna behave, service suggesting, target marketing. By all the companies around the world, this is getting used in this way. And that's the reason Spark streaming is gaining the popularity. And because of its performance as well, it is beating all other platforms at the moment. Now, moving further, let's see Spark streaming features. When we talk about Spark streaming features, it's very easy to scale. You can scale to even multiple nodes, which can even run till hundreds of nodes. Speed is going to be very quick, means in a very short time you can stream as well as processor data. Fault tolerant, even it makes sure that even you're not losing your data. Integration with your batch time and real-time processing is possible, and it can also be used for your business analytics, which is used to track behavior of your customer. So as you can see, this is so powerful, right? In each slide, we are kind of getting to know so many interesting things about this Spark streaming. Now, let's quickly have an overview so that we can get some basics of Spark streaming. Now, let's understand how it works. So as we have just discussed, it is for real-time streaming data. It is useful addition in your Spark Core API. So we have already seen at the base level, we have that Spark Core in our ecosystem. On top of that, we have Spark streaming. In fact, Spark streaming is kind of adding a lot of advantage to Spark community, because a lot of people are only joining Spark community to kind of use this Spark streaming. It's so powerful that everyone wants to come and want to use it, because all the other frameworks which we already have, which are existing, are not as good in terms of performance and all. And it's the easiness of using Spark streaming is also great. If you compare your program with, let's say, Flume or with Storm, which is used for real-time processing, you will notice that it is much easier in terms of from a developer point of view as well. That's the reason a lot of people are showing interest in this domain. Now, it will also enable a high throughput and fault tolerant, so that to stream your data, to process all the things up. And the fundamental unit for Spark streaming is going to be DStream. What is DStream? Let me explain it. So DStream is basically a series of RDDs to process the real-time data. What we generally do is, if you look at this right hand side, when you get the data, it is a continuous data. You divide it into batches of input data. We are going to call it as micro batch. And then we are going to get batches of process data. Though it is real time, but still how come it is batch? Because definitely you are doing processing on some part of the data, right? Even if it is coming at real time, and that is what we are going to call it as micro batch. Moving further, now let's see few more details on it. Now, from where you can get all your data, what can be your data sources here? So if we talk about data sources here, now we can stream the data from multiple sources like Parquet, Upka, Kafka. Even you have static sources like HBase, MongoDB, which are your NoSQL DBs, Elasticsearch, PostgreSQL, Parquet file format. You can get all the data from here. Now after that, you can also now do processing with the help of machine learning. You can do the processing with the help of your Spark SQL and then give the output. So this is a very strong thing, that you are bringing the data using Spark streaming, but processing you can do by using some other frameworks as well, right? Like machine learning, you can apply on the data what you are getting at a real time. You can also apply your Spark SQL on the data which you are getting at the real time. Moving further, so this is a similar thing. Now in Spark streaming, you can just get the data from multiple sources, like from Kafka, Flume, STFS, Kinesis, Twitter, bringing it to the Spark streaming, doing the processing, and storing it back to your HDFS. Maybe you can bring it to your DB. You can also publish to your UI dashboard like Tableau, AngularJS. A lot of UI dashboards are there in which you can publish your output. Now, how it works, let us just break down into more fine-grained contents. Now, we are going to get our input data stream. We are going to put it inside our Spark streaming, going to get the batches of input data. Once it executes through a Spark engine, we are going to get batches of process data. We have just seen the same diagram before, so the same explanation for it. Now, again, breaking it down into more granular part, we are getting a DStream. DStream was what? Small RDDs of data, multiple set of RDDs. So we are getting a DStream. So let's say we are getting an RDD at the rate of time 1, because now we are getting real stream data, right? So let's say in today, right now I got 1 second, maybe now I got 1 second, in 1 second I got more data. Now I got more data in the next lot, right? So that is what we're talking about. So we are creating data we are getting from time 0 to time 1. Let's say that we have an RDD at the rate of time 1. Similarly, it is just proceeding with the time. The RDD is getting proceeded here. Now, in the next thing, we are extracting the words from an input stream. So if you can notice what we are doing here, from here, let's say we started doing our operations as well. We started doing our any sort of processing. So as and when we get the data in this time frame, we started doing some processing. It can be a flat map operation. It can be any sort of operation you are doing. It can be even a machine learning operation or whatever you are doing. And then you are generating the words in that time frame. So this is how we are seeing that how granularly we can kind of see all these parts at a very high level. This work, we again went into detail, then again we went into more detail, and finally we have seen that how we can even process the data along the time when we are streaming our data as well. Now, one important point is, just like Spark context is a main entry point for any Spark application, similarly, to work on streaming, Spark streaming, you require a streaming context. What is that? When you're passing your input data stream, when you are working on the Spark engine, when you're working on the Spark streaming engine, you have to use your streaming context here. It's using streaming context only, you are going to get the batches of your input data. Now, so streaming context is going to consume a stream of data in Apache Spark. It is registers and input DStream to produce a receiver object. Now, it is the main entry point, as we discussed, that like Spark context is the main entry point for the Spark application. Similarly, your streaming context is an entry point for your Spark streaming. Now, does that mean now Spark context is not an entry point? No. When you create Spark streaming, it is dependent on your Spark streaming only. So when you create this streaming context, it is going to be dependent on your Spark context only, because you will not be able to create streaming context without Spark context. So that's the reason it is definitely required. Spark also provide a number of default implementations of sources, like you can get the data from Twitter, a character, 0MQ, which are accessible from the context. So it is supporting so many things, right? Now, if you notice this, what we are doing in streaming context, this is just to give you an idea about how we can initialize our streaming context. So we will be importing these two libraries. After that, can you see? I'm passing Spark context, SC, right? So I'm passing it every second. We are collecting the data, means collect the data for every 1 second. You can increase this number if you want, and then this is your SSC. It means in every 1 second, whatever going to happen, I'm going to process it. This is what we are doing in this case. Let's go to the DStream topic now. Now, in DStream, it is, the full form is discretized stream. It's a basic abstraction provided by your Spark streaming framework. It's a continuous stream of data, and it is going to be received from your source and from processed. Streaming context is related to your Spark streaming part. Spark context is belonging to your Spark core. If you remember the ecosystem, Rahul, in the ecosystem we have that Spark context, right? Now, streaming context is built with the help of Spark context, and in fact, using streaming context only you will be able to perform your Spark streaming. Just like without Spark context, you were not able to execute anything in Spark application. Your Spark application will not be able to do anything. Similarly, without streaming context, your streaming application will not be able to do anything. It's just that streaming context is built on top of Spark context. Okay, great. Now, it's a continuous stream of data. I can talk about these three. It is received from source or from a processed data stream generated by the transformation of input stream. If you look at this part, internally a DStream can be represented by a continuous series of RDVs. This is important here. Now, what we are doing is every second, remember last time we have just seen an example of like every second whatever going to happen, we are going to do processing. So in that every second, whatever data you are collecting and you're performing your operation. So the data what you're getting here is will be your DStream. Means it's a content, you can say that all this thing will be your DStream part. It's a representation by a continuous series of RDD. Can you see so many RDDs getting formed? Because let's say right now in 1 second what data I got collected, I executed it. In the second this data is happening here. Okay, sorry for that. Now in the second time also it is happening here. Third second also it is happening here. No problem now. I'm not going to draw it now. Fine. So in the third second also, if I did something, I'm processing it here, right? So if you see this diagram itself, so it is every second whatever data is getting collected, we are doing the processing on top of it. And the whole continuous series of RDD, what we are seeing here, will be called as DStream. Okay, so this is what your DStream. Moving further. Now, we are going to understand the operation on DStream. So let's say you are doing this operation on this DStream, that you are getting the data from 0 to 1. Again, you are applying some operation on that. Then whatever output you get, you are going to call it as words DStream. Means this is the thing what you're doing a platform operation. That's the reason we are calling it as a word DStream. Now, similarly, whatever thing you're doing, so you're going to get accordingly an output DStream for it as well. So this is what is happening in this particular example. Now, flat map is a API. It is very similar to map. It's kind of flatten up your value. Okay. So let me explain you with an example. What is flat map? So let's say if I say that, hi, this is Edureka. Welcome. Okay, let's say this is written. Now I want to apply a flat map. So let's say this is a form of RDD also. Now on this RDD, let's say I apply flat map. So let's say RDD, this is the RDD, flat map, sorry, capital S, flat map here. And then let's say you want to define something for it. So let's say you say that, okay, you are defining your variables here. Okay, so let's say a dot. Now after that you are defining your split. So you're splitting with respect to this. Now in this case, what is going to happen? Now I'm not showing you the exact thing here, just to explain you flat map, just to kind of give you an idea of how it works. It is going to flatten up this file with respect to the split what you have mentioned here. Means what? It is going to now create each element as one word. So it is going to create like this: hi as one word, as one element, this as one word or one element, is as another word or one element, Edureka as one word or another element, welcome as one word or another element. So this is how your flat map works. Kind of flatten up your whole file. So this is what we are doing in our stream as well. Clear, Rahul? So this is how this will work. Now, so we have just understood this part. Now let's understand input DStream and receivers. Okay, what are these things? Let's understand this part. Okay, so what are the input DStream possible? There can be basic source, advanced source. In basic source, we can have file systems, sockets, connections. In advanced source, we can have Kafka, Flume, Kinesis. Okay, so your input DStreams are the DStreams representing the stream of input data received from streaming sources. This is again the same thing. Okay, so there are two types of streams which we just discussed. One is your basic and second is your advanced. Let's move further. Now what we are going to see here. So if you notice, let's say here there are some events occurring. It is going to your receiver, and then in the DStream now RDDs are getting created and we are performing some steps on it. So the receiver sends the data into the DStream where each batch is going to contain the RDD. So this is what your DStream is doing, receiver is doing here. Now, moving further, transformations on the DStream. Let's understand that. What are the transformations available? There are multiple transformations which are possible. The most popular, let's talk about that. We have map, flat map, filter, reduce, group by. So there are multiple transformations available here. Now it is like you are getting your input data. Now you will be applying any of these operations, means any transformation step is going to happen, and then a new DStream is going to be created. Okay, so that is what's going to happen. So let's explore it one by one. So let's start with map. If I start with map, what happens with map? It is going to create batches of data. Okay, so let's say it is going to create a map value of it like this. So let's say X is mapped to B, Y is giving the output C, Z is giving the output A, right? So in this similar format, this is going to get mapped. So it is going to, whatever you are performing, it is just going to create batches of input data which you can execute it. So it returns a new DStream by passing each element of the source DStream through a function which you have defined. Let's discuss this flat map. Flat map we have just discussed. It is going to flatten up the things. So in this case also, if you notice, we are just kind of flattening up. It is very similar to map, but each input item can be mapped to 0 or more output in items here. Okay, and it is going to return a new DStream by passing each source element through a function for this part. So we have just seen an example of flat map anyway. So that same example, you can remember that. That will be more easy for you to kind of see the difference between with map itself. Now, moving further, filter. As the name states, you can now filter out the values. So let's say you have a huge data, you want to filter out some values, you just want to kind of work with some filtered data. Maybe you want to remove some part of it, maybe you are trying to put some logic on it. Does this line contain this, right? Or does this line contain that? So in that case, it is filtering only with that particular criteria. So this is what we do here. So definitely most of the times your output is going to be smaller in comparison to your input. Reduce. Reduce is, it's just like it's going to do kind of aggregation on the work. Let's say in the end you want to sum up all the data what you have. That is going to be done with the help of reduce. Now after that, group by. Group by is like it's going to combine all the common values. That is what group by is going to do. So as you can see in this example, all the things which are starting with C got group by, all the things names starting with J got group by, all the names starting with T got group by. Now, so again, what is this stream window? Now, to give you an example of this window, everybody must be knowing Twitter, right? So now what happens in Twitter? Let me go to my paint. So in this example, let's understand how this windowing operation works. So let's say in initial first second, 10 seconds, let's say the tweets are happening in this way. Let's say hash A, hash A, hash A. Now, which is the trending tweet here? Definitely A, right? A is my trending tweet. Maybe in the next 10 seconds, now again hash A, hash B is occurring. Which is the trending tweet? B is happening here. Now, let's say in another 10 seconds, now this time, let's say hash B is happening. Now, which is trending? B is occurring. But now, I want to find out which is the trending one in last 30 seconds. Hash B, right? Because if I combine, I can do it easily. Now, this is your windowing operation example. Means you are not only looking at your current window, but you are also looking at your previous window. When I say current window, I am talking about, let's say, 10 seconds of slot. In this 10-second slot, let's say you are doing this operation on hash B. So this is your current window. Now, you are not only computing with respect to your current window, but you are also considering your previous window. Now, let's say in this case, if I ask you, can you give me the output of which is trending in last 17 seconds? Will you be able to answer? No. Why? Because you don't have partial information for 7 seconds. You have information for your 10, 20, 30, means multiple of 10, but not intermediate one. So keep this in mind, okay? So you will be able to perform windowing operation only with respect to your window size. It's not like you can create any partial value and can do the window operation. Now, let's get back to the slides. Now, it's a similar thing. So now it is shown here that we are not only considering the current window, but we are also considering the previous window. Now, let's understand the output operations of the DStream. When we talk about output operations, so output operations are going to allow the DStream data to be pushed out to your external system. If you notice here, means whenever whatever processing you have done with respect to whatever data you are doing here, now your output you can store in multiple places. You can store it in the file system, you can keep in your database, you can keep even in your external systems. So you can keep in multiple places. So that is what being reflected here. Now, so if I talk about output operation, these are the ones which are supported. We can print out the value. We can use save as text file. When we use save as text file, it saves it into your HDFS. If you want, you can also use it to save it in a local file system. You can save it as an object file also. You can save it as a Hadoop file, or you can also apply for each RDD function. Now, what are for each RDD function. Let's see this example. So generally we explain all this parts in detail once we teach you in Edureka sessions, but just to give you an idea. Now this is a very powerful primitive that is going to allow your data to be sent out to your external systems. So using this, you can send it across to your out to your external systems. We have just seen our external system that it can be a file system, it can be anything. So using this, you will be able to transfer it. You will be able to send it out to your external systems. Now, let's understand the caching and persistence. Now, when we talk about caching and persistence, so DStream is also allowing the developers to cache or to persist the stream's data in memory. Means you can keep your data in memory. You can cache your data in memory for longer time. Even after your action is complete, it is not going to delete it. So you can just use this as many times as you want. So you can simply use your persist method to do that. So for your input streams which are receiving your data over the network, maybe using Kafka, Loom, sockets, the default persistence level is set to the replicate the data to 2 nodes for the fault tolerance. Like it is also going to be replicating the data into 2 parts. So you can see the same thing in this diagram. Let's understand this accumulators, broadcast variables, and checkpoints. Now these are mostly for your performance part. So this is going to help you to kind of perform, to help you in the performance part enough. So it is accumulators is nothing but a variable that are only added through an associative and commutative operation. Usually, if you are coming from Hadoop background, if you have done, let's say, any MapReduce programming, you must have seen something about counters. Right? That there we used to have a counters, which kind of helps us to debug the program as well, and you can perform some analysis in the console itself. Now, this is similar thing you can do with the accumulators as well. So you can implement your counters with this part. You can also sum up the things with this part. Now you can, if you want to track through UI, you can also do that. As you can see in this UI itself, you can see all your accumulators as well. Now, similarly, we have broadcast variables. Now, broadcast variables allow the programmer to keep a read-only variable cached on all the machines which are available. Now, it is going to be kind of caching it on all the machines. Now, they can be used to give every node a copy of a large input data set in an efficient manner. So you can just use that. Spark will also attempt to distribute the distributed broadcast variable using efficient broadcast algorithm to reduce the communication cost. So as you can see here, we are passing this broadcast value. It is going to Spark context, and then it is broadcasting to this places, right? So this is how it is working in this application. Generally, when we teach in these classes and also, since these are advanced concepts, we kind of try to explain you with the practicals and all. Right now, we just want to give you an idea about what are these things. So when you go with the practicals of all these things, like how accumulators, see how this is happening, how it is getting broadcasted, things become more and more clear at that time. Right now, I just want that everybody at least get a high level overview of things. Now, moving further, so what is checkpoints? So checkpoints are similar to your checkpoints in the gaming. Now they can they make it run 24/7, make it resilient to the failure, unrelated to the application logic. So if you can see this diagram, we are just creating the checkpoint. So as in the metadata checkpoint, you can see it is the saving of the information which is defining the streaming computation. If we talk about data from checkpoints, it is saving of the generated RDD to the reliable storage. So this both are generating the checkpoint. Now moving forward, we are going to move towards our project where we are going to perform our Twitter sentiment analysis. Let's discuss a very important use case of Twitter sentimental analysis. This is going to be very interesting because we will just do a real-time analysis on Twitter sentiment analysis. And there can be a lot of possibility of this sentiment analysis, but we will be taking something from the Twitter, and it's going to be very interesting. So generally, when we do all this in our course, it is more detailed, because right now in the webinar, definitely going in deep is not very much possible. But during the training of Edureka, you learn all these things within the class. Awesome, right? That's something which we learn it during the session itself. Now, if we talk about some use cases of Twitter, as I said, there can be multiple use cases which are possible, because there are a lot of emotions behind whatever the campaign you are doing, right? So much of social media right now in these days are very active as well, right? You must be noticing that even politicians have started using Twitter, and that all their tweets are being shown in the news channel, and in fact they become a hot trending tweet. People start talking about positive, negative when any politician do something, right? And if we talk about anything else, even if we talk about, let's say, any sports, FIFA World Cup is going on, then you will notice always Twitter will be filled up with a lot of tweets, right? So how we can take use of it, how we can do some analysis on top of it, that's what we are going to learn in this. So there can be multiple sort of sentiment analysis, like it can be done for your crisis management, service adjusting, target marketing. We can keep on talking about when a new movie is released. Now even the movie makers kind of go and try to predict, okay, how this movie is going to perform. So they can easily make out even beforehand, okay, this movie is going to go in this kind of range of profit or not. So interesting, right? Earlier days it was not even possible. Even in the political campaign, in fact, you must have heard that in US when the president election was happening, they have used, in fact, a lot of social media, all this analysis and all, and that have in fact played a major role in winning that election. Similarly, how whether investors want to predict whether they should invest in a particular company or not, whether they want to check that whether like we should target which customers for advertisement, because we cannot target everyone. Problem with targeting everyone is that if we try to target everyone, it will be very costly. So we want to kind of set a target. Okay, these may be my set of people whom I should send this advertisement to be more effective, and as well as it is going to be cost effective as well. If you want to review the products and services also, in that case, we can also do this. Now, let's see some use cases. Like in terms of use case, I will show you a practical how it runs. So first of all, we will be importing all the required Spark packages, because we are going to now perform total sentiment analysis. So we will be requiring some packages for that. So we will be doing that as a first step. Then we need to set all our authentication. Without authentication, we cannot do anything else. Now here the challenge is we cannot directly put your username and password, right? Don't you think it will get hacked if I put your username and password, right? So Twitter came up with something very smart thing. What they did is, they came up with something called as authentication tokens. So you have to go to dev.twitter.com, log in from there, and you will find kind of all this authentication tokens available to you. 4 will be there. You need to take them and put it here. Then, as we have learned the DStream transformation, you will be doing all that computation here. So you will be having a DStream transformation. Then you will be generating your tweet data and going to save it in this particular directory. Once you are done with this, then you are going to extract your sentiment. Once you extract it, and you're done. Let me just show you quickly how it works in our VM. Now, one more interesting thing about Edureka would be that you will be getting all this configuration machines. So you need not worry about from where I will be getting all this. Is it like very difficult to install? When I was going in this open source location, it was not working for me. In my operating system, it was not working. So many things we have generally seen people face issues. To resolve everything up, we kind of provide all this VM. Question from Rahul, this VM has pre-Spark? Yes, that's what. It has everything pre-installed, whichever will be required for your training. So that's the best part what we also provide. So in this case, your Eclipse will already be there. You need to just go to your Eclipse location. Let me show you how you can also go there if you want. As you can see, when Eclipse is there, you just need to go inside it and double click on it and start. You need not go and kind of install Eclipse and all. Even the Spark will already be installed for you. Let us go in our project. So this is our project which is in front of you. So this is our project which we are going to work on. Now you can see that we have first imported all the libraries, then we have set all our authentication systems, and then we have moved and kind of extracted the DStream transformation, extracted the tweets, right? And then save the output finally, right? So these are the things which we have done in this program also. Now let's execute it. To run this program, it's very simple. Go to run as, and from run as, click on scale application. You will notice in the end, it is, Rahul is saying that's great. Good to see that. So it is executing the program. Let this execute. And we are doing it actually for Trump. So usually for Trump anyway, the tweets are going to be negative, right? So let's see that. Because anything you do for Trump is going to be negative. Trump is anyway the hot topic for us. Let me make it a little bigger also. You will notice a lot of negative tweets coming up for him. Yes. Now, I'm just stopping it so that I can show you some tweet. Yes, it's filtering the tweet for Trump. So we have actually, while writing the program itself, we have given it one location Trump. Using that, we were kind of asking for a tweet of Trump. Now, here we are doing analysis, and it is also going to tell us whether it's a positive tweet, negative tweet. As you can see the negative tweet is coming up, right? Because for Trump, anyone will not tweet positive, right? So that's something which is there. So that's the reason you're finding this as a negative tweet. So similarly, if there will be any other tweet which will be getting a status. So right now, if I keep on moving ahead, we will see multiple negative tweets which will come up. So that's how this program runs. Okay. So this is how our program we will be executing. We can just extract it. Even the output results will be getting stored at a location. As you can see in this, if I go to my location here, this is my actual project where it is running. So you can just come to this location. Here are all your output. Okay, all your output is getting stored there. So you can just take a look as well. Yes, so it's everything is done by using Spark Streaming only. Okay, that's what we have seen, right, Rahul? That we were seeing it with respect to DStream Transformations and all. So we have done all that with the help of Spark Streaming only. So that is one of the awesome part about this, that you can do such a powerful things with respect to your with respect to your this part. Now let's analyze our results. So as we have just seen that it is showing up whether it's a positive tweet, negative tweets and all. So this is where your output is getting stored. I've just shown you up. The output will appear like this. Okay, this is just your output tweets and sentiments. It will also tell whether it's a neutral one, positive one, negative one. Everything we have done it with the help of Spark Streaming only. Now we have done it for Trump, as I just explained you, right? We have put in our program itself Trump, like we have put everything up here, and based on that only we are getting all this output. Now we can apply all the sentiment analysis and like this, like we have learned. So I hope you have found all this, especially this use case, very much useful for you to kind of getting at that. Yes, it is getting done by hashtag. Right now we have put Trump here, but if you want, you can keep on putting your hashtag as well, because that's how we are doing it. You can keep on changing your tags. Maybe you can kind of put for, let's say, for FIFA World Cup is going on, a cricket match will be going on. You can just put the tweets according to that. Just tweet in that place, instead of Trump, you can put any player name or maybe a team name, and you will see all that trending tweet coming accordingly. Okay, so that's how you can play with this. Now, there are multiple examples with it which we can play, and this use case can be even evolved for multiple other type of use cases. You can just keep on transforming it according to your own use cases. So that's it about Spark Streaming, which I wanted to discuss. So I hope you must have found it useful. Do we get these kind of projects in the Spark course? Yes, you will learn it during the sessions itself. And usually at the end, you will be finding multiple projects to practice as well. But during the sessions also, trainers kind of give you a good overview of all this project, how to work on it, because at the time you're learning it. So our motive is, when we are teaching you something, we kind of explain you with a use case. So that way you kind of learn in a better way, rather than telling you this, do that. If you see it in a use case, you kind of learn a lot. And that's the Edureka way of making you learn. What if we get stuck in these projects? We have a 24/7 support from Edureka side. If you get stuck at any moment, just drop an email, give them a call, and you will be immediately assisted. Nothing can be awesome than this, right? So if you are not going to be left out, even if you are kind of getting freeze with that kind of a project, even with the trainers also, you can kind of have your sessions. They will be helping you with the cost with all that. So that's not a problem with us. Fantastic. Thanks a lot for the wonderful session. Thanks, Rahul. Thanks, Nitin. So I hope all of you have found this session quite useful. So this is all about the Spark streaming site. I hope our path meets once again. I hope we see you back in Edureka. So thank you, everyone.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!